If you have someone in your life that's always talking about cars and you never know what they're talking about, this video is for you. This is an engine block. It's a big block of steel that makes up most of the engine. It has holes in it, and those holes are cylindrical in shape. This one has 6 holes. That means it's a 6-cylinder. All of those cylinders are in a straight line. That means that it's an inline engine. So you'll hear this referred to as a 6-cylinder inline, or an inline 6, or a straight 6. This is also an engine block. It also has 6 cylinders, but these ones aren't in a straight line. These ones make a V shape. So this is a V6. A V6 is a pretty standard engine. A V8 is going to be for a very powerful vehicle. The inline 6 doesn't vibrate as much, so it tends to be for a smoother ride on higher end sporty vehicles, as opposed to our Prius, which has an inline 4-cylinder, which is a much less powerful engine. There are other engine shapes, but these are the 2 most common. Those cylinder holes essentially work like one of these, that they have a plunger that goes in and out, and that plunger is called a piston. The vehicle uses gasoline to cause tiny explosions that make that piston go in and out, and the engine converts that back and forth motion to a spinning motion. To create motion, cars use tiny little fires inside the engine. To make fire, you need fuel, oxygen, and heat. The fuel that most of us use is gasoline, and this is the gas tank right here. It's at the back of the vehicle, far away from the engine, because the engine has fire in it. It can get really hot, and you don't want this to explode. And on some vehicles, like this one, it's on the passenger side. That's farther away from the driver. Inside that tank, there is a small electric pump called the fuel pump that pumps gasoline through a hose up to the engine. That's sometimes referred to as the low pressure pump, because there's another fuel pump by the engine called the high pressure pump. Then the fuel goes to this, which is called a fuel injector. The gas comes in the top and it is sprayed out of the bottom. It works a lot like one of these, where it sprays that gasoline out into a mist. Because it sprays the gasoline like this, it mixes that gas with the oxygen around it, and that's where the oxygen comes from to make the fire. And then all we have left is heat, which comes from the spark plug. Right here, there's 2 pieces of metal, and electricity has to cross from one piece to the other, and that makes a spark. This is a cross section of an engine to show what this looks like. Here we have the cylinder, that is the piston, and this is the spark plug and the fuel injector. Air comes in this pipe here and then mixes with the fuel from the fuel injector. And then the spark plug lights it on fire, and that creates a lot of energy that moves the piston down. And then when the piston moves back up, it pushes the bad air out this way, and that's the exhaust. So a V engine is going to look like this, where you have pistons on either side making this in the middle turn. So if you have 4 or 6 or 8 or 16 of these cylinders, they each need to be going at a slightly different time, and they all have to go in the right order. So timing is really important. This space inside the engine where the fire is made is called the combustion chamber. Sometimes it's shaped like a tent, sometimes it's shaped like a wedge, sometimes it's flat, and sometimes it's a half circle or a hemisphere. When it's a hemisphere, that's called a Hemi. So if you hear someone talking about their truck having a Hemi, that's what they mean. Older vehicles don't have fuel injectors, they have what's called a carburetor. Fuel goes in the side and air comes in the top, and it mixes together to create a fuel and oxygen combination. Gasoline has a lot of hydrogen and carbon mixtures in it called hydrocarbons, and what this does is it mixes those hydrocarbons with oxygen, and that's why it's called a carburetor. Another thing that some engines have is this. This is called a turbo. The bad air that comes out of an engine, the exhaust, it comes out quickly because it's forced out. That exhaust goes in right here and it spins a small fan called a turbine. That turbine is attached to a rod that comes to another fan right here. That fan sucks clean air in and pushes it into the engine. It puts some force behind that air. Forcing air into the combustion chamber is like blowing on a fire. It really makes it hotter. More air means more energy and a more powerful engine. So let's use what we've learned to break down what this engine is. This is a W16 quad turbo engine. W means it should be shaped somewhat like a W. 16 cylinders, it has 8 on each side. And quad turbo means it has 4 turbos. It has 2 on each side, and you can see it has these pipes that force that air into the engine. This is a very powerful engine that goes in a Bugatti, and just this engine alone costs more than $800,000. The engine spins all kinds of things, mainly the tires, but there are a lot of other things that it spins using what's called a serpentine belt. It's called that because it kind of goes through the engine compartment like a snake. If you ever have a vehicle and it starts making that sound, that's usually the serpentine belt going out. These are cheap and not really that difficult to replace depending on the vehicle. It spins fans and pumps and anything that might need to be spinned around. One of the things that it spins is the alternator. The alternator is like an electric motor, but instead of using electricity to create a spinning motion, it's using a spinning motion to create electricity. It takes kinetic energy from the engine and turns it into an alternate form of energy. Electricity. That's not why it's called an alternator, but it might help you remember. The electricity from the alternator charges your battery and helps electricity things run. Another very important part of a vehicle is the transmission. If you were going to go on a mission to Mars, you would need a rocket ship, which is exactly what a transmission looks like. If we look at the bottom of a car where the engine is right here in the front, this is the transmission. And it has a shaft that comes out of it that powers the back tires. The inside of a transmission is full of gears and stuff, and it essentially does the same thing that this does on your bicycle. It changes gears. Essentially, by shifting between larger and smaller gears, you can change how much energy it takes to make the tires turn a full rotation. So this is what the gears on the inside do. The engine provides power to this green gear that makes this red shaft called the lay shaft spin. And so those red gears spin these blue gears. But those blue gears are not attached to this shaft here. This shaft is attached to these purple things. So the blue part is spinning because of the engine, and the purple part is spinning along this shaft, which is connected to the rear tires. So however the rear tires are spinning, that's how this shaft and those purple parts are spinning. This diagram shows a manual transmission where you have a lever here that you can use to move these purple parts back and forth. And that way you can connect them to the blue gears. So if I take this purple part and I connect it to this gear right there, then this whole shaft is going to rotate at the same speed as that gear. That would be first gear, where I have a very small gear turning a very large gear. That means that it'll use a lot of energy from the engine to make a small amount of rotation, which is good for getting a car to start moving. Once the car is already moving, you want that same amount of energy from the engine to do more in terms of rotating the wheels. And for that reason, these gears, as we move along, get larger, and these gears get smaller. So here we have first gear, second gear, third gear, fourth gear, and fifth gear. And then this last one here on the end has an idle gear in the middle. So this gear turns that gear, which then turns that gear, which means that this blue one right here is moving in the opposite direction as all of these other ones here. So if you move this purple piece over to that and connect it, that's going to put the car in reverse. So when you're driving in your car and you hear it go, that's when one of these purple pieces goes from one of these gears and then shifts over to connect to a different gear. If you didn't shift gears, then you would get to where the engine is rotating at a slower speed than the wheels in the back, and your engine will actually start to slow down the wheels. And you can even start to have energy coming from your back tires speeding up your engine. You can damage your engine that way. Some cars like my Prius have a continuously variable transmission, and that means it doesn't have all of those gears in there. Instead, it has what looks like two big pulleys, and they have a belt that goes between them that's made out of metal. But each of these pulleys is actually made out of two cones that can be squished together or separated apart. And if they squish together, then that means that the belt goes more towards the outside of the cone, and it makes it like a big gear. And when you move them away from each other, that belt then moves in towards the middle, and it's like making it a small gear. This way you can have vehicles that have very smooth transitions between gears. Or you might not have gears at all, that you never have that shifting that happens. because you can make it a slow and gradual shift from a slow gear to a high gear. So these transmissions look like this. And there are other kinds of continuously variable transmissions, which are called CVTs, and some of them look like this with two big cones, and there are some newer ones that look like two ball joint looking things. But if you hear someone talking about a continuously variable transmission or a CVT, that just means that the transmission doesn't have all that network of gears. There are some advantages to a CVT, one of them being that it's a very smooth ride. But if you're going to be towing things or really off-roading, going up giant mountains, this is going to work better. And this kind of transmission gives you much more satisfying vroom vroom sounds. While these transmissions might make a little bit of an annoying hissing sound when it changes gear. Between the back two tires, there is an axle. And in the middle of that axle, there is this thing. That is called the rear differential. When a vehicle goes around a turn, the two back tires need to spin at different speeds. This has gears in it that allows them to do that. The differential, different speeds. That thing is full of lubricant, and the number one problem that it has is that it will leak and then it needs to be fixed. Now the front tires are held on by a bunch of rods and stuff. These have various names like control arm and tie rod and anti-roll bar and ball joint. Any kind of bar or joint or rod is probably one of these parts. These are what connect the front wheels to the car. They suspend the car in the front, so they're called the front suspension. So if you hear someone talk about rebuilding the front suspension, this is what they're talking about. When we look at the bottom of a car, we have the engine compartment in the front, and then we have these pipes that go along the undercarriage and come out the back. The engine creates bad toxic air called exhaust, and that exhaust is put through these pipes. It's like the farts of the vehicle. And the first thing it's going to do is go through what's called a catalytic converter. Sometimes people will call it a CAT. Catalytic converters take pollutants out of the air. They're like filters. They make the exhaust less toxic and less terrible for the environment. They are also full of very expensive metals, so people tend to steal them. After the catalytic converter, you have the muffler here near the rear. The muffler is like a silencer. It takes all the noise from the engine and it makes it quieter. If you get a hole in this pipe anywhere before the muffler, it's gonna make the car really loud. Sometimes people will do this on purpose. They'll take the muffler out and just have a pipe that comes out the back. But when you do hear someone with a really loud vehicle, don't assume that they just bypassed the muffler. They might have had their catalytic converter stolen, and that sucks. When you look at an engine, you can see all these little holes that are in the engine block. These are for different liquids to flow through the engine. One of those fluids is engine oil and the other is coolant. While it's running, this engine has thousands of tiny little fires in it. And it has a lot of moving parts, which means it has a lot of friction. And it uses coolant, which is antifreeze and water, to make sure it doesn't get too hot, and that flows all through that engine block. The reason that's used instead of water is because the boiling point is higher than the boiling point of water, and it won't freeze until it gets at least 35 degrees below zero. That way, when you start your car in the winter, it's not full of ice. There's a water pump that attaches directly to the engine, and it pushes that coolant into the engine block. It's powered from this wheel that is spun by the serpentine belt. When the coolant comes out of the engine, it goes to a thermostat that decides, is the coolant too hot or too cold or just right? If the coolant is cold, it'll come in here, it'll bypass the whole cooling system and will go straight back into the water pump and into the engine. If the coolant is too hot, then this whole valve will go down, it'll be cut off from the bypass, and that coolant will go up into what's called a radiator. And if the coolant is just right, it'll sit right in the middle and it'll be able to flow back to the engine and to the radiator. The radiator is this big sheet-looking thing that's right behind the grill. It's called a radiator because it works exactly like one of these that you see inside a house, and it radiates heat. If you cut a car's radiator in half, it'll look like this. These here are flat little pipes, and those are what the coolant is going through. That coolant is snaking its way all the way down this radiator from the top to the bottom. And in between those pipes, air is able to pass through. All of the heat is transferred from that coolant to the air. While you're driving, the motion of the vehicle forces air through the grill and through the radiator. But while you're idling, you still need to cool your engine, so there's also one or two big fans that pull air through that radiator. So all it's really doing is taking a hot liquid and cold air and having them pass by each other to make a cold liquid and hot air. And after that cooled down coolant goes through the radiator, it goes right back to the water pump into the engine. There's one other thing that the coolant is used for in the car, and that's to go to this. This is called the heater core. It's essentially another smaller radiator that's closer to the cabin of the vehicle. This does the same thing that the big radiator does, but the air that blows through this then goes into the car. And that hot air is what makes your car warm. So when you turn the heat on in your car, it's using the hot coolant from the engine to create that heat. The last thing about this that's good to know is that this whole system is under pressure. And when liquids get hot, they expand. And you don't want it to get so hot that the whole system starts to explode and spring leaks and have just hot coolant shooting out everywhere. So there are a few places in the system where there are vents, where if the pressure gets too high, that coolant can escape the system. One of those vents is in the radiator cap, which is that cap that says, don't touch this when the engine is hot. Water will burn your skin. When it gets to about 105 to 110 degrees, this coolant can get over 200 degrees. And inside that radiator cap, there is a spring that pushes down on this valve right there. So if this coolant right here has too much pressure, it will push that spring up and that coolant will escape and go to a reservoir. And that reservoir feeds the coolant back into the system. What is power steering? Well, this is what the steering system in your car looks like. You have your steering wheel up there, and that turns this shaft here that's connected to this bar, which is called the rack. The rack is not an axle. It does not spin, but it is attached to other bars that are attached to the tires. So when this moves left and right, that makes the wheels turn left and right. A very simple steering system would be one that this connects right here. There's just a gear there, and when you turn the wheel, it moves that bar right and left. That wouldn't have any of these other things, but it's really, really hard to turn. All of these parts are filled with power steering fluid, which is under pressure, and it's put under pressure because of the power steering fluid pump. That pump is operated by the serpentine belt. After the pump, it goes into this spot right here, which is called the rotary valve. The rotary valve will push that fluid down one of these two lines. If it goes down this line, this area here will fill with power steering fluid and push on this piston, and it'll push that piston this direction, helping that rack move that way. And if that power steering fluid is pushed down this line, it'll push against that piston that way, helping the rack move this way. The pinion, which is this rod that is attached to the steering wheel, is still what decides how far that rack is going to move. But that power steering fluid pushing against that piston makes it move really smoothly. Of course, if that piston moves this direction, then all of this fluid in here has to be pushed out. It has to go back into the rotary valve, and that will end up going out back to the reservoir or back to the pump. So all of the direction of the flow of that hydraulic fluid is based on what happens in this rotary valve. So here's a cutaway of the whole system. You have the rotary valve, the two lines that go to the rack right there, and then the pinion here that actually controls how far it can move. That's the piston that can move back and forth based on which side that hydraulic fluid is being pumped into. Now you could design a steering system that is entirely hydraulic, that doesn't even have this pinion here, that it just forces fluid into one side or the other, and that decides which direction the tires go in. The steering of that would be really easy, but it would not be safe, because you get a leak in this, you cut one of those lines, and suddenly you can't turn your car at all. Since this is actually the control of the vehicle right there, if you cut these lines, you can still turn. It's just really, really hard. What you might have noticed if you're ever driving and then your engine dies while you're driving, which is not great, you suddenly realize that it's really hard to steer. That's because the serpentine belt isn't moving. That means the pump isn't moving, and this isn't under pressure anymore. So these are designed to have a nice balance between how much this does and how much this does. You want enough pressure here that it's pretty easy to turn the wheel, but you really want to have enough control here that you can feel that turn, that it's not too easy. And this being connected mechanically to the wheel, to the rack, which is connected to the tires, makes a continuous connection from the road to your hands. And that makes it so you can really feel the road conditions with your hands. If your brakes are grinding, you can feel it in your foot at the pedal, but you can also feel it in the steering wheel. If the bearings in your wheel are going bad and they're starting to grind, again, You can hear it, but you can also feel it in the steering wheel. So if you're ever driving and you're like, man, something feels very wrong at the steering wheel, it's connected that way on purpose so that when things go wrong, you can feel it. And another thing you might hear car people talk about is chasing gremlins or chasing ghosts. That means there is an electrical problem in the car, but they can't figure out what it is. Vehicles have wires going everywhere. And any one of those wires becoming severed or coming loose can cause all kinds of problems in the car. Sometimes finding which wire has the problem is very time consuming. So those little electrical glitches are called gremlins or ghosts. So if you have a friend who is chasing gremlins in their vehicle, they're having a bad day. It's really frustrating. When other parts break, like, you know what the problem is, but that sucks. So hopefully this helps you understand a little bit more about what's going on in your vehicle.